Alright, hello all. So I am going through example 1 on slide 3 for April 25th. So here it says ethanol and acetic acid react to form water and ethyl acetate. And so we have our chemical equations here. So we have ethanol and acetic acid is a reversible reaction with ethyl acetate plus water. And water in this case is part of the reaction. And so it wants to know when we initially have 1 mole in 1 liter, so we have 1 molar of ethanol and ethyl acetate, how much product or what will be the amount of the product we will have at equilibrium, and then what is the equilibrium constant. So when we set up these problems for figuring out at equilibrium what do we have in the reaction so that we can find the equilibrium constant, we always set up an ice table. And so it tells us in the problem that at equilibrium the amount of reactants we have left is 1/3 the amount we start with. And because we have 1, then we have just 1/3 of the amount of reactant left. And so because Q is going to equal 0 because we have no products, we know that the reactants is going to form products. So we know we're losing reactants, so we're going to put a minus in the change, and we're adding products, we're going to add those. So how much products and how much reactants do we add? So we lost 2/3 of our reactants in the change because we have 1/3 left, we just subtract that from 1. And then we know that we gain 2/3 of the product because of the law of conservation of mass. You can't lose mass, so if everything works out, we'll gain 2/3 our products, and everything's at the 1-to-1 ratio. So we have our amounts at equilibrium. So now we're going to plug this into our equilibrium constant equation, or our reaction quotient for at equilibrium. And so we know that the reaction quotient is the ratio of the products to the reactants. So for this one, we have our ethyl acetate and our water. And then we know squared or anything because it's a 1-to-1 ratio in our balanced chemical equation. And then we have our concentration of ethanol and acetic acid. Okay. And then we're going to plug in at equilibrium what are the concentrations. So for the products, we have 2/3 for each. And for our reactants, we have 1/3. And then when we math that out, right, we'd multiply the top, multiply the bottom, divide, we get 4 as our equilibrium constant for this reaction.